So as Tatsung said, I work for Spotify. You may be familiar with Spotify. It's an app you have on your phone. Frequently people use it for listening to music. And you can see here some examples of playlists you'll find on Spotify app. For example, top hits, which are ranked by popularity. We have playlists that are compiled according to the genre in conjunction with music experts. And we have the very popular Discover Weekly, which is very personalized and finds music you haven't listened to before, but that'll be surprising and interesting for you. And we also go beyond music to music and talk. And so I'm going to talk a little bit about both of these today. The podcasts, one style of talk audio we have on Spotify. We've got third-party podcasts, Spotify-made podcasts. They're make-your-own podcasts, apps that you can upload podcasts to Spotify. And then more generally, Spotify's goal is to enable you to listen to everything all in one place. So we have music, we have podcasts, and now we have audiobooks. And so you can easily switch between your favorite songs, shows, and stories. Then more generally, Spotify's mission is to unlock the potential of human creativity by giving 1 million creative artists the opportunity to live off their art and billions of fans the opportunity to enjoy and be inspired by it. And one of the reasons I find this mission statement quite inspiring because the goal is not to enable a small number of very big artists to be listened to by everyone, but rather to enable many, many artists to earn a living with their music content, with their podcast content, and find an audience for all of those very varied artists and creators of different kinds. So one of the ways we do that is by matching artists and fans in a personal and relevant way. And that's something that's easy to say, but it can be harder to do. And so, in particular, I'm based in Spotify Research, where we have a number of research areas to help us with this Spotify mission. We work on algorithmic responsibility, we work on audio intelligence, we work on language technologies, we work on machine learning. And some of the things I'm going to talk about today touch on various of these areas. So one of the ways that Spotify and other companies match, in this case, artists and fans or content and users, is via the structural relationships between the items and the behavior of the users. So, for example, let me see a moment if I can point. Well, okay, so we have the artists on the left, they're in our catalogue, and then in yellow down the centre you can see that the items in the catalogue are linked via playlists, so collections of songs that have co-occurrence relationships. Podcasts have episodes that are part of shows. And then we have the user behaviour such as searching, browsing, voice queries and listening. And the traditional collaborative filtering model, for example, would take that user behavior on that content and use that for recommendation. Another kind of thing we can do with this structural data is to say, take the co-occurrence of songs and playlists and use that to infer a kind of similarity. And these structural relationships and behavior are really useful for our matching of creators and fans because it's agnostic to the type of content, it's agnostic with respect to the language, and it works really well when it works. But some of the requirements for it to work is that we have, for example, enough user behavior, or that we have enough co-occurrence data. And so sometimes this will break down when we don't have, when we're in the cold start setting where we don't have so much behavioral or structural information about our content. So what I want to focus on today is going beyond just the structural, but also looking deeper into the content itself, and in particular focusing on the multimodal nature of our content. And when we can understand our multimodal content deeply, we can use that in part to decorate the edges on our graphs to enable our models to work even better, or in and of themselves as a ways of understanding our content and using that for matching users and fans in a very relevant way. So, if we think about a song on Spotify, we don't normally think of that as a multimodal kind of thing. It's a piece of audio, you listen to it. So I just want to kind of illustrate some of the different kinds of multimodal pieces of that content. So we have, for example, the cover art of a song. or of an album, and that's something that may indicate something about its style. You think, if any of you remember record stores or have gone to any retro record stores, people flip through the albums, and the cover art is in fact one of the first things people see when they're deciding whether to try out a new piece of music. We also have the artist name, so this song here is by Taylor Swift. She's very popular, and that name alone might encourage people to want to listen to that, and that will tell us something about what style it is, who likes that music. The song has a title, and then also we have lyrics associated with that song. And so I'm going to talk a little bit later today about what the lyrics and the audio can tell us about what style of song we might be listening to. Also on the podcast side, we have multimodal elements we might think again of as a plain piece of audio, but they come with cover art, they come with a title, they come with a description, and depending on what we do with the audio, one kind of thing we can do is pass it through speech recognition and then have a noisy piece of text that it conveys the entire content of that podcast. And so one of the reasons it's interesting to look at that transcript is that it's, while perhaps errorful, describes completely what is in the podcast, whereas the description is a shortened, abbreviated version of what's in the content. And then to drill down a little more into podcasts, they have other, even within the relationships, such as episodes, part of shows. They have title and description, and if we drill down into the transcript even further, we might be able to identify timestamps, who's speaking, and so on. So what I want to do today is just talk about 3 different sets of research we've done in my group, looking at different multimodal aspects of this data. I'm going to talk about, from the song's point of view, looking at lyrics in conjunction with acoustics. On the podcast side, I'm going to talk about speaker turn-taking and also the speech style of the podcasts. One of the kinds of things you see in music listening, people sometimes looking for specific songs, but sometimes they're looking for music that matches a mood they have. So they're looking for happy songs, or love songs, or songs for working out. And you can see playlists associated with these things. Some users will create a playlist, for example, Happy Vibes 2023. Spotify makes playlists. Music experts will compile these things such as timeless love songs. People also occasionally looking for sad songs to sort of help them work through some emotions. That's another kind of way that people like to potentially find music. So when we've got the songs in a playlist already, then we can, we're in a position to make recommendations on that basis, but we'd like more generally to be able to identify the moods associated with a song, even when we don't have it already in a playlist annotated with that. So we can conduct some research to look at the perceived mood of a song based on both its lyrics and acoustics. So I have the song Cardigan here by Taylor Swift. And if we look at and analyze the lyrics, we might say this song is about sadness, it has longing, it has heartbreak. And one little excerpt of the lyrics goes, and I'm not going to sing this for you today, but maybe somebody else will sing this later tonight if we get to some karaoke. But 'cause I knew you, stepping on the last train, marked me like a blood stain. I knew you, tried to change the ending, Peter losing Wendy, I knew you. And you kind of hear from those lyrics, it's sort of a mournful sounding song. But if we look at the acoustics, we have in the Spotify API some features for music understanding developed by our music IR team. We find that it's high tempo, upbeat, and calm, which we wouldn't necessarily associate with sadness, longing, and heartbreak. And there's an interesting piece of work by Interanio et al., published in 2018, did an analysis of trends over 30 years, showing that song lyrics have been getting sadder on average over the last 3 decades, but acoustically the songs have become more danceable and relaxed. So they're not always showing the same thing through the acoustics and lyrics, and sometimes perhaps that contrast between a more upbeat acoustics and a more melancholy lyrics kind of gives an overall even more melancholy feel. So starting from a set of songs tagged with moods by the users, for example, placed in playlists with a mood associated with it, we investigated how machine learning models could be designed to automatically associate moods with songs in order to enable listeners to search and discover music according to a mood. And then more generally, we wanted to understand how much the lyrics and acoustics of each song contributes to that understanding. So we also included the acoustic features. We used a BART model. We considered both zero-shot and fine-tuned BART model. We fed the lyrics and a description like "this is a sad song" to BART models in a couple of different configurations to assess whether the model identified as an entailment or as a contradiction. We then concatenated the numerical features through a multi-layer perceptron and then fine-tuned a model to classify the mood of the song. If we just look at the lyrics, we found that we get quite high precision and recall for the lyrics model when it's fine-tuned to the task. And fine-tuning to that task improves over zero-shot. And it's always going to be the question in everybody's talk these days. I haven't compared this to what you would get from ChatGPT, but I encourage you to try out later. Feed some Taylor Swift's lyrics in and ask ChatGPT if that's a sad song. I'd be curious to see what you find. But in any case, with a small model that we can get from Hugging Face, we're a relatively smaller model, we can get quite good precision and recall based on the lyrics model. And when we add the acoustics, the performance goes up. But the majority of the signal is in the lyrics, which is sort of what our intuition told us. But with acoustics alone, in case we don't have access to the lyrics, for example, if it's there's sort of a separate process for getting lyrics for songs, and if it's a song that we don't have the lyrics for, we could get some mileage out of the acoustics alone. When we drill down into particular moods, we find that for love, the lyrics predict the mood better than the hybrid model, which includes acoustics. And then chill is better predicted from the hybrid model, although our overall performance on that category is lower than it is for love. And so I guess we could say that love songs are more reliably predictable, and chill perhaps contains more diversity of types of songs and more diversity of types of lyrics. And so this paper was published in ICWSM last year. And now I want to turn to podcasts and talk a little about speaker turn-taking. So when we look at podcasts and try and analyze the number of speakers in them, some of them are monologues, a large number are dialogues with 2 speakers, but we see podcasts with 3 speakers, 4 speakers, and so on. And so we could use that information about how many speakers there are, how they're speaking in relation to each other to understand something about the content that might help us with our recommendation. So for example, the person speaking first may be the host of the podcast, the guests on the podcast may be the people who speak the most. The turn-taking can help us understand something about the genre. For example, if it's a monologue is one style of podcast, an interview may have short questions followed by longer answers of 2 speakers interleaved. And then speaker overlap, for example, if there's very clear turn-taking between the speakers, that might be a formal genre podcast, whereas if speakers are speaking over each other, then that can indicate excitement. You'll see that sort of thing in humorous podcasts, in sports podcasts, and so on. So if we wanted to get at that signal, how many people are speaking, how are they taking turns, what's going on in that process, we want to do the task which is known as speaker diarization, and so that's logging the speaker turns in a long piece of audio. I want to stress that this is an anonymous process. We're not connecting the audio of anyone's voice to their real name, to their identity in the real world, but just to say we have 2 speakers speaking in alternation, 3 speakers speaking in alternation, and identifying, say, speaker 1, speaker 2, and so on. So we take the audio timeline, let's say we have the green speaker and the blue speaker, we find those segments, and then we say, okay, that speaker 1 speaks first, and then again after a certain timestamp later, and then again, and then that's the last person to speak. And even looking at this structure here, we could say, we might infer something like speaker 1 is the host, and we might be able to use that information to find similar podcasts perhaps with that same person as a host. Similarly, we say that these matching blue regions would be for speaker 2, and that person as a guest could also be appearing on other podcasts as a guest. So this can kind of help us infer relationships between podcasts. So there are a number of traditional approaches to diarization. Typically, the audio signal is embedded into a numerical form. Then the embeddings are clustered. Typically, you need to identify the number of speakers in advance. So in this case, say the person's identified 3 speakers, and then there's post-processing to find when there's overlap between the speakers. Some drawbacks with this approach is that when it's a hard clustering, it makes it hard to detect overlap. As I said, you need to know this number of speakers in advance, which can be a challenge. Language-dependent embeddings often perform better for this task, but that means that then we're restricted to languages that we already have trained a model for. Whereas intuitively, you could listen to a pair of people speaking a language you don't understand and be able to say, okay, that was speaker 1, now somebody else started talking, now somebody else started talking. So having the model dependent on the language feels like over complication that shouldn't be strictly needed in order to accomplish this task. And then doing this as an end-to-end supervised approach, it can be susceptible to bias, which can lead to unfairness because we have to balance the data set for gender, age, race, and so on of the speakers. And then all of this counterbalancing can lead the size of the data needed in a supervised setting to grow exponentially, and it's also difficult to annotate data sets like that. So it can be quite challenging to do the traditional approach. My team has developed a newer method of unsupervised, overlap-aware, and scalable diarization that then can be done in a language-independent approach. So we have audio-only embeddings that are not reliant on the text or the language specific to the podcast. And then a sparse optimization phase that removes the clustering and post-processing phase that then is overlap-aware and it doesn't require tuning. And also because it's unsupervised, we don't require manual annotation of training data. And that again allows us to be scalable to many, many languages, to many, many environments. So essentially we take the audio file, we run it through some standard featureization, so we use YAMNet and VGGVox to get our embeddings. We find regions that don't have speech, which YAMNet can help us with, and then for the regions that do have speech, we conduct the speaker diarization to mark each unique embedding pattern in time. And we approach this as a matrix factorization problem. So we can see on the left each square horizontally is a timestamp, and then vertically is the representation of a single speaker. So we can see in the yellow, brown, yellow region in timestamp 3, that's a speaker who continues speaking, speaker 1 continues speaking for 5 units of time in this case. And then speaker 2, a little time later, is speaking for 4 units of time there. And the nice thing about this representation is that we can then create an embedding matrix that has a column for each speaker. And then we have an activation matrix which shows when each speaker is speaking. And if there is, since it's a sparse factorization, we can set any column to 0 when we don't need an additional speaker to represent our data. And since we want this to be independent of the number of speakers, we iteratively test to find the right number of speakers so that it doesn't need to be manually input by sorting the singular values in descending order and then finding a knee where that seems to be closely associated with the actual number of speakers. So when we evaluate this model, we find that it exceeds the commercial baseline available from GCP. We've also compared it to Keynote 1.1 and 2.0, which are supervised models. So although Keynote 2.0 exceeds this model, it's a supervised model trained on a relatively small number of languages, whereas our approach is language independent. So to conclude, the advantages of this sparse optimization approach to diarization is we don't have to provide the exact number of speakers. It's completely audio-based and language independent. It's an unsupervised algorithm, and it's massively parallelizable. And so then this paper was published in Interspeech last year. So then the third perspective on podcast content and understanding podcast content I want to turn to is about speech style. And there's an interesting piece of work by Martin de Rijk and colleagues a few years ago, where they manually annotated podcasts with some attributes and asked podcast listeners what were important to them. And what they showed with some of the things that were important were things like the topic of the podcast, the guests, but then also other things such as the way the podcaster speaks, so the fluency, the presence of hesitations, the speech speed, and so on. And then also audio-based things such as an opening jingle, background music, and so on. And so we wanted to drill down onto this podcaster category and see if we could, since this was a manually annotated set, we could automatically derive these features and see if they're also predictive of listener engagement on podcasts on Spotify. And one of the reasons it's kind of interesting is because podcast creators are always trying to make their content more appealing to listeners, and they get common sense speaking advice. You can find blogs, you can find different pieces of advice, but it's not always clear whether that advice is validated by data. And so, for example, one piece of advice gives you suggests how to speak slowly on the podcast under the assumption that that's something that listeners would appreciate. And then there's your pros and cons of swearing on your podcast. Does that make you more authentic, or does that turn off listeners? So we, in this study, we took a 100,000 podcast data set and filtered it down to episodes that had sufficient length and listening history. And we had to do that for these experiments because we wanted to connect the content of the podcast to the listening behavior. But more generally, when this approach works, we can apply it to podcasts for which we don't have any listening behavior. So it can help us with the cold start problem with recommending podcast contents when we don't have that listening history. So we have the transcript of the audio. We also have the titles and descriptions written by the podcast creators. And we created an episode engagement metric, which is a 5-minute stream rate among first-time listeners of the podcast on Spotify. And the reason we did that was because we want to have a sense, loyal listeners might listen to a podcast whether or not it has swearing, but we're interested in if somebody's listening to this for the first time. Is this something that they will keep listening to? Is this something that they find appealing without having history with that podcast? And so then we defined a number of speech style features over the podcast, some of them inspired by Martin de Rijk's paper, other ones inspired by popular podcast creation advice. For example, are there emotion words being used? Is there swearing? Is there diversity of vocabulary? Are there ads? What is the speech rate of the speaker? So now we'll really find out whether you should be speaking fast or slow on your podcast. And the popular advice says to keep your podcast succinct. Swearing you're generally told to avoid swearing, but maybe you could keep a little bit for character. The description is recommended to be relevant. This is before we've done our analysis. I'm just telling you the advice you'll get on blogs about how to create a podcast. You're encouraged to be upbeat and positive in emotions, to reduce or edit out fillers, so that's the ums and ahs. And in fact, there you'll find that so more professional podcast creators, for example, people with a radio background, have software that they edit out the ums and ahs. You're encouraged to have diverse vocabulary, find your own voice and style, and then ads, reduce the ads, but include show notes and description. And the recommendation is to speak slowly. So in order to actually test these suggestions, we binned the data by popularity quartile. If we didn't do that, we'd find the stream rate is weakly inversely correlated with popularity. So we want to try and remove that effect by binning into 4 popularity bins. And then in each of those bins, divide the data into the top 25% and bottom 25% of episodes by engagement. And then for each feature, we compute the difference of means between the 2 sets with bootstrap t-tests. So most of the advice is validated. So compared to low engagement episodes, high engagement ones have long and relevant descriptions, they have fewer ads, they have more show notes and ads, they have less swearing, they have higher vocabulary diversity and high reading grade levels, and they have more positive emotions and fewer negative emotions. But on the other hand, high engagement ones have lower distinctiveness in contrast with the popular advice. They have faster speech, and they have fewer fillers, but only in the lowest popularity quartile. And then generally they have more adverbs and conjunctions, fewer nouns and pronouns. So, and we found that overall that the textual content is highly predictive of engagement. So when we have a 50% prior on our model, the speech style features and logistic regression can get us a 71% accuracy. Obviously, well, maybe not obviously, but if we don't consider those style features but just look at a BERT model or a TF-IDF model, we can do even better. So these are not enough alone to predict engagement, but they give us some very interesting things and also validate advice that's given to podcasters. And it's another dimension that we can use to look at our podcasts beyond the language itself. And so, for example, something like speech speed, again, we might be able to compute for podcasts where we don't know the language or we don't have a transcription of it. We still might be able to estimate the speed based on the audio alone. So the takeaways from this piece of work is that most podcast creation advice is validated by the data with a few contradictions and new insights. The linguistic content can distinguish between high and low stream rate with nearly 81% accuracy on the data set, and the speech style features alone get 71% accuracy. And this paper was published in ACL in 2021. And so just to recap, we've looked at three different aspects and modalities of podcasts, the lyrics and acoustics for songs, the speaker turn taking for podcasts, and also the speech style for podcasts. And then if we can overlay these kinds of information onto our other structural, behavioral content, then we can be in even a better position for matching our artists and fans in meaningful and relevant ways. So I just want to talk briefly about the podcast data set that we've used for some of these experiments. And one of the things we found when we started working at Spotify is we want to publish our papers. We need a data set that other people can access and compare their results against. So we produced a data set of podcasts in 2020. And you can access it, you can get to it from the Spotify research webpage where we have other data sets as well. For example, the Million Playlist data set from Wisdom in 2019. If any of you are in Australia, we there had a data set for the Wisdom Cup, which was a music streaming sessions data set. And we also have the Open Mic audio crowdsourced instrument labels data set. So this podcast data set we initially released as an English language set. And it has about 100,000 podcasts where each podcast is typically, well, on average about 40 minutes long. And we provided the metadata, the raw audio file, and the machine-generated transcript. It's about 60,000 hours of audio, or 2 terabytes, and 600 million word transcripts. And I have to say with the caveat, there is no user ratings or behavior data in this, so we can't reproduce all the experiments I've talked about there because some of them do rely on having user behavior data. But in any case, this, at least the time we released it, was orders of magnitude larger than previous speech collections. Since then, we've been expanding our data to add another language. So Portuguese is a language spoken by 260 million people, largely in Brazil, also in Portugal and several other countries. And so we have now a sample of Portuguese podcasts also in our data set, with similar numbers of episodes. They're relatively similar in terms of length and maybe a little longer than the English podcast data. And so now we've been able to use this to compare algorithms on 2 different languages and to also look at when we can do things in a more language independent way. And so we've done some experiments on some summarization in this data set where we combine English and Portuguese to test on Portuguese and find that we can do even better by having more languages in our data set. And so you can obtain this data set from the Spotify research website. And then I just wanted to thank all my colleagues and collaborators who have worked together on this multimodal experimentation.